the t results. T is tan of half the angle, so tan x on 2. And if I know that, sine x is 2t on 1 plus t squared, cos x is 1 minus t squared on 1 plus t squared. But if I differentiate that, I can create another t result, which is useful for integration. The t dx, differentiated with respect to x, I'll get a half of sec squared, which I can write as 1 plus tan squared, but we just said tan of x on 2 is t, so it becomes a half of 1 plus t squared. Play around with that, I get this new t result. It's a t result for dx. It's 2 to t on 1 plus t squared. The beauty is the denominator of all three of these t results is the same. They're all 1 plus t squared. It allows me to turn a trig integral into a polynomial. I can get rid of the trig. It'll only work, of course, when I have sine and cos. They're the t results I'm going to use. So I'm going to do the substitution. T is tan x on 2, and dx then is 2 to t on 1 plus t squared. Let's substitute in. Dx is 2 to t on 1 plus t squared, 7 plus 6 lots of 1 minus t squared on 1 plus t squared. Denominators are nicely the same. Multiply out. Now, reality, when I'm doing my working out, that second line I don't usually put down, because I know I'm setting up something where the denominators are all the same. Just write the numerators, but any constant I remember to multiply by 1 plus t squared. I can go straight to this line here. That gives me 2 to t on 13 plus t squared. That is inverse tan. 2 on root 13, the inverse tan of t on root 13. T was what I introduced. Let's put x back into it. So it's the tan of x on 2 on root 13. There it is. So tempting to go inverse tan times tan, but remember you got this over root 13, so you can't. They won't cancel there. It doesn't have to be tan x on 2. I could use t equals tan x. If I did that though, that's going to change my t result for the other one as well. I end up with dx is the t on 1 plus t squared, not 2 to t on 1 plus t squared. In general, if you've got x on a, 9 times out of 10 it's going to be x on 2. What happens? Well, let's do the mathematics behind it. Differentiate, and that's what I end up with. Notice the position of the a. It's always with the t. So that denominator is going to be 1 plus t squared every single time. But whatever the x is over, that's how many to t you'll end up with. If you did do the substitution of t equals tan x, then it's 1 to t. If I wanted to do x on 3 for some insane reason, then I would have 3 to t on 1 plus t squared, and so on. Okay, so we'll just add those few questions there.